again on this Wednesday for our, okay, this is the last topic for our syllabus. That is, today we proceed with relative motion analysis, RMA, and the last one is kinetics part. Because for the dynamic, we have kinematics, that we have learned rectilinear, curvilinear, and the third one is relative motion analysis, and the last one is kinetic. Okay, so for those not scan the QR code, please scan the QR code first for the attendance. Okay, today's motivational quote is, it is not enough to do your best. You must know what to do and then do your best, by W. Edwards Deming. Okay. Alright, so as I mentioned just now, today we will proceed with relative motion analysis and kinetics. Okay, previously you have learned about, okay, previously you have learned about rectilinear. Okay, and for the rectilinear, it is direct. This means for the rectilinear, I think the knowledge is what you have learned from previously, but for the, because for the displacement, for the velocity, for the acceleration is the same formula as it is dsdt, dvdt, and you need to integrate and differentiate to get the this means from velocity to get the acceleration, you need to differentiate. Okay, that is for the equation. And from the graph, um, the integration is the area under curve, and the differentiation is the gradient of the graph. That one is you need to understand. And for when the velocity is start from rest, it is means that it is start from zero. That means the velocity is zero and it is start to move, so it have the velocity. And then the okay, and for the area and the graph, if it is negative, you need to insert also the negative value in the calculation of the area to get the that's mean if you want to get the if you want to get the displacement from the VT graph, and some of it is negative, you need to put the negative value. That's mean not only area based on the width and the length, but you need to put in also the value of the negative, because for the parameter is vector, so vector, the positive and negative is important. Okay, that one is for the rectilinear. And for the curvilinear, you have learned about, okay, what are the formula that okay, okay, after this I will share you the formula that we given for the in the final exam. But for the test, because it is only specific. That means for the test, it only dynamic and rectilinear and curvilinear. So the equation will not given. The equation, the list of the equation will be given in the final exam. Okay, what are the equation for the XY curvilinear that you need to remember. You can write in the chat or you can speak up. Please, you need to remember that formula. The formula that you need to use, that means there are three main formula that derive from the A equal to V minus U over T. So from that, there are three formula that it is the basic formula that you will use for the curvilinear XY coordination. What are the formula? Okay, V equal to U plus AT. Okay, that is the first one. And then what else?
V squared equal to U squared plus 2AS.
Okay, thank you, Irfan. V square equal to U square plus 2AS. And another one?
S equal to UT plus half AT squared.
Okay, S equal to UT plus half AT squared. So for S, this one is S minus S naught. That means the displacement from the start of the motion. If the S naught is not zero, you need to put the S naught there. That means if it start on the building or it start on the some displacement, you need to put the displacement there. Okay, there are three main equation for the curvilinear in the xy direction. Okay, this one is the main. And then based on that three main equation, you need to know for the y direction and x direction. Okay, for the y direction, for the maximum is the velocity is 0. And for the velocity of the velocity in the x direction is same for uh, Vx is same, but for the Vy the maximum point is 0 and the same level is same. And then the A, the acceleration in the equation, you need to change into gravitational acceleration, that is negative 9.81. Okay, so that is the uh, for the y y formula. That's mean y analysis in the y direction. So after that, for the x, for the x, the velocity is same for every location. So Vx is actually same with Ux. And then for the Vx, for the x analysis, there are no acceleration. This mean you no need to use the g there, because for the x analysis, we not use this mean there is no acceleration in the x direction. Okay, so there is the xy curvilinear, and then we have normal tangent. Okay, for the normal tangent, for the curvilinear motion, and we can resolve it into normal, that is toward the center of the rotation, and also the tangent. And the tangent is actually same as the direction of the velocity. So we have v tangent and v tangent exists and normal exists. And for the acceleration, okay, for the velocity first. For the velocity, the v given, if the equation given the velocity, it is actually the v tangent, and there are no v normal, no v normal because there are no velocity toward the center. But it's different with the acceleration because uh, with the velocity toward same with tangent direction, it will create the acceleration in the tangent and also acceleration in the normal. And for the acceleration in the normal, the equation is v squared over rho. That means the rho is the radius of the curvature and the v is the v tangent, the velocity of the particle. And for the acceleration in tangent, acceleration of the tangent is dv dt. That is if it's given the let me see. Okay, for the if it okay, for the tangent, v tangent, it is the rate of change of the speed. So if given the equation of the speed, you can get the acceleration by differentiate the speed equation. So there is the tangent normal. And the last one, previously you have learned about the curvilinear in angular coordination. Okay, for the angular coordination, we have r and theta. And r is the position, this means from the point, and it is position vector to the particle in the motion. And then the theta is the degree from the axis. If degree from the axis, and then okay, for the angular analysis, we need to have the d dr dt and also dr d theta, because the coordination is r and theta. So for the velocity analysis, need to consider both of it to get the value of the velocity and also acceleration. Okay, that is for the kinematic in the curvilinear motion. Okay, so now we proceed to the relative motion. Okay, previously we have learned the motion in the straight line, the motion in the curved path. So that is about motion. Okay, and then now we consider how about the okay, relative motion can be defined as the motion of the body is moving with respect to another body which is either moving or at rest. This means there are relatively toward each other. So it is relative motion. Okay, so we watch this video first. I start sharing again. Okay.
Suppose you are traveling in an open car. Just for fun, you throw an apple out of it. Now you can observe an intriguing phenomenon. After hitting the road, the apple suddenly starts to follow you. How do you explain this crazy behavior? Let's get into it. When you hold the apple inside the car, it feels like the apple is at rest. However, relative to the road, the apple is moving at the same speed as the car. When you throw the apple from the car, You are in fact giving it a velocity opposite to its initial velocity. This opposite velocity reduces the apple's net velocity. The apple still moves in a forward direction, but with a lower velocity than the car, which means the apple will slowly move away from the car. Even after hitting the road, the apple will continue to have a forward velocity. So the apple has a forward velocity before and after hitting the road. Why do we feel like the apple was moving backwards before it hit the road? Here comes the trick our brain plays. Until the apple hits the road, the brain analyzes the situation in reference to the car. By that frame of reference, the apple has a velocity opposite to the car, the initial velocity you gave it when you tossed it. So you feel like the apple is moving backward. However, after the apple hits the road, your brain analyzes the movement of the apple in reference to the ground. Here, obviously, the apple has a forward velocity, and you feel like the apple suddenly starts to follow you. In short, this interesting phenomenon happens because your brain changed its frame of reference between you tossing the apple and the apple hitting the ground. This example is just an introduction to the world of relative motion and reference frames. Welcome to this interesting world.
Okay, all right. So,
Suppose you are traveling in an open car. Just for fun, you throw an apple out of it.
all right.
Now you can
Okay. From the video, what do you understand from the relative motion? Okay, from what he explained, and also there are certain term or keywords in the video. Okay, so please share the term that you have found, and if possible share also the meaning of the terms from this video in the Padlet. Okay, I give you 5 minutes to share what you get from this video.
Doctor,
Yes.
can you share the the code again?
Oh,
Okay, then, doctor. okay. From the video,
It also state the, okay, as one of you state, it is constituting a frame of reference. Okay, you also can share also here the definition of the frame of reference. Because in my slide I will not share about it. So search the term of frame of reference and share the meanings here. Forward velocity, motion relative to each other. Relative motion is a motion observed from or referred to some material system constituting a frame reference. Velocity of the object in reference to other moving object. Yes, that's mean before this we not consider the motion. That's mean who observe the motion. But now we consider that in our life there are many objects moving. So there in this subtopic, that's mean in this topic, we will learn about the motion relative to motion of one object relative to other object. Either the other object is moving also or at rest. Okay. Right. A frame. Okay. Thank you who share here. Okay. A frame of reference is an abstract coordinate system whose origin, orientation, and scale are specified by a set of reference points. Okay. Actually, it is a frame of reference is because here when before this in the rectilinear curvilinear we refer to this means we not consider that we only focus on that kind of the motion. So okay, because the frame of reference is okay, a frame of reference can be thought as any spot we are doing measurement from as long as it is not accelerating. Okay, so that means the reference of doing the measurement as long as it is not accelerating. Okay, motion related to each other. Okay, relative motion means motion related to each other. Reference frame will affect the observation of the motion. Okay, frame of reference is okay. This determine the position and velocity of object in that frame. Different frame of reference move relative to one another. Okay, maybe after this you can because it is a bit tricky the definition of the frame of reference. Okay, but as in the relative motion, it's considered frame of reference. Okay, thank you for all the sharing. Okay.
Suppose you are traveling in an open car. Just for fun.
All right. So it is same example here. That means this is another example. Suppose you are traveling with other passenger in a train that is moving at 40 km per hour. Have you noticed that you appear stationary to the other passenger? That means when you are in the train, you look like not moving. You are stationary to the other passenger. But if someone sees you from the outside of the train, your motion appears similar to the train velocity to them. This means if someone sees you from outside, you actually moving the same speed with the train. So there is the relative motion. So the theory of relative motion will help us understand why this motion appear different for different observer. This means for the passenger, each of the passenger see the velocity is zero. Even the train is moving with velocity of 40 kilometer per hour. But if someone sees from outside, actually sees you with the moving of the speed same as the speed of the train. So there is this situation we will learn the analysis in this topic. Okay, so relative motion. Okay, so all motion have various appearance or perspective as we view them from different frame. Hence, whenever two body interact, these different frames describe the motion between interacting bodies as a relative motion. So that means if the relatively between the passenger, you will see the velocity is zero. But if the relative motion between passenger and the person outside, it will see you moving with the same speed with the motion of the transportation. Okay, relative is when two moving bodies interact with each other, then we can say their motion is relative. Relative, this means compared to, this means compared to each other. Okay, relative to whom is okay. The motion of two moving bodies might look different for different observers based on which frame they observe. Okay, the for relative motion, it use many. This mean many time the word the term frames. Okay, so it is like the coordinate or the yes, the coordinate of the observer and the motion. Therefore, the motion is relative to the observer's frame. Okay, so this is the based on the observer's frame. Okay, so there are we can okay, another example. This means another explanation. Suppose you are standing at side of the road and watching all other vehicle passing by. Here, you are the observer and your position is not changing. Hence, the motion of the vehicle is absolute to the observer position is not changing with time. But when you travel in a car, you watch other vehicle passing by from the car window. You may notice the vehicle are moving slowly past you, even though you know their actual velocities. Those are very high. This occur because of their relative motion between your car and other vehicle as the observer position change with time. Okay, I think you are understand now. That means when you are static, you are not moving. So when you are side of the road and the car move pass by you, you can feel that the car move very fast. But when you are when you are in car and you see another car side by you, so the vehicle are not very fast compared when you are standing outside stationary. That means not move. So this is the meaning of the absolute motion and relative motion. Okay, so absolute motion means when the motion of the body is observed from a fixed point. So it is said to be absolute motion. And then compared to the relative motion is when there is no fixed point, because when you are in car, you are not fixed, you are not on a fixed point, you are moving point. So for observing the motion of the body, it is said to be relative motion. And for the absolute motion, the body's position does not vary with time. But for the relative motion, the body's position vary with time. So this is the the relative motion. Okay, before this, we learn about the absolute motion. That means we just observe from the outside. We look the motion of the car on curvilinear. We observe the motion of the ball throwing from top of the building. That means we see outside. We are not moving, but when we see, we as observer, and we are in moving state. So that's why we cannot analyze with previous theory. That means we cannot analyze from the basic rectilinear and curvilinear theory, but there are other theory that we need to apply is relative motion, because now as the observer, you are moving, you are not static. Okay, so this is the absolute motion and relative motion. Okay, so RMA is a relative motion analysis. Okay, for the displacement, okay, this is the position of this means position when we learn in rectilinear. And for the relative motion analysis of displacement, so if we have the displacement of A, displacement of B, so displacement of A relative to B is SAB. So that means relate the displacement of A, okay, here, relative to B, actually AB, okay, here. This means from B minus A, okay. So this is the equation. Displacement of A relative to B is SA minus SB. Okay, so for me, I is this mean like this I like to remember this equation more compared to this one. You can use this equation or this, that actually it is same, but somehow maybe you will confuse which one will minus which one. Okay, when it is A relative to B, it is A minus B. When it is B relative to A, it is B minus A. But if you want to use this, just rechange it. So SB is SA plus SBA. But for me, I prefer to remember this equation first, and then can rewrite the another equation. Okay, so this is for the displacement. And for the, okay, that one is for the rectilinear, and for the curvilinear, same. This means if it is RA relative to B, it is RA minus RB. RB relative to A, it is RB minus RA. Okay, but here you need to consider the direction of okay, for SA relative to B, it is from A to B. The arrow of the relative displacement. If is B relative to A, start the arrow at B first. Sorry, jap. Balik ke. Jap. Displacement A relative to B. It is AB. Relative. Okay. Sorry. It is opposite. Displacement A relative to B. It is start at B. So displacement A relative to B. Okay, start at B and go to the A. If it is displacement B relative to A, okay, start at A and then go to B. Okay, so this is the SAB. So that's why for the equation SAB is SA minus SB, and because SA is smaller than SB, that's why we get the negative, so it is toward the left. Okay, so this is the formula and also the arrow direction. The same with the displacement in the curvilinear. Okay, we have the RA and RB, position of A and B. So relative motion and displacement of A relative to B is RA minus RB, and it is start at B, this one, start at B to the A. And if is relative, the displacement of B relative to A, start at A, go to the B. So this is for displacement. And then for the velocity is actually the same equation. Okay. Previously RB displacement of B relative to A is RB minus RA. So for the V, just change the V. This means for the VBA, it is VB minus VA. And also for the A, acceleration, differentiate with differentiate with the time with respect to time against, and it we will get A B. This means acceleration of B relative to A, it is AB minus AA. Okay, so that is the equation. Okay, for the analysis, the relative velocity in rectilinear is the velocity of the particle in the direction of the motion. And for curvilinear, the velocity of the particle is tangential to the curve and the direction of the motion. So this is the relative velocity. And for the acceleration, okay, for the rectilinear, when particle is accelerating, the acceleration is in the direction of the velocity. But if it is decelerating, the acceleration is opposite to the direction of the velocity. And for curvilinear, acceleration is resolved into two components, normal and tangential. Okay, so this is the normal. So as same as the curvilinear normal tangent coordinate. So for the AN, it is V squared over rho. And for the AT, it is dV dt. This is the analysis similar to the rectilinear motion. Okay, for the direction of the AN, the direction of the AN is toward the center of the curvature, that is in the positive direction of the normal axis. And for the tangential component of the acceleration, when when it is accelerating, the t is in the direction of the positive velocity. But if it is decelerating, it is in the direction of negative velocity. When it is constant velocity, so at is equal to 0. Okay, so this is the analysis for the relative acceleration. Okay, there are two methods for analysis. Okay, for example here, okay, so figure show the plane B fly with a speed of 70 kilometer per hour to the west, and plane A fly 600 kilometer per hour to the southeast with 35 degree from the ground. Determines the speed plane B relative to the plane A. Okay, so uh, get the VBA. Okay, please try this example first. Okay, so the one two four. Okay, someone have got the answer 1240.2 kilometer per hour. Okay, so actually, okay, this one, when you see it is okay, when you see it is in the kilometer per hour. So it's okay. You can solve with the kilometer per hour, or you can solve by meter per second if the question not ask you to change it. But if the question asks you to change it, you need to change it. Okay. Do you know how to change from the kilometer per hour to the meter per second? Okay, this is the solution. So in the okay, I got the answer in the meter per second. Uh, okay, so for the kilometer per hour, okay, here the kilometer per hour here, and then how to change to the meter per second is, can you get the kilometer per, and then you need to, okay, to change the kilometer to the meter, one okay, 1000 meter per kilometer, and then hour, okay, 1 hour is, okay, this is 1 hour 1 hour is equal to 60 minutes, and six and 60 minutes, sorry, 1 minute is equal to 60 seconds. So you need to change it. 1 minute equal to 60 seconds. You can cross it, cross the kilometer, cross the hour. So you should get the meter per second here. So actually you need to times the meter. Alright. So okay, so this is the formula to change from the kilometer per hour to meter per second. So you need to times by 1000 over 3600 to get the from kilometer to the meter per second. Okay, so as previously uh, it is it can, okay, previously it said that we can solve the analysis for the RMA by rectangular and the trigonometry method. Okay, so the first method here is rectangular method. Okay, from this, okay, we have the VA is equal 600 kilometer per hour and VB is 700 kilometer per hour. Okay, this one is changed from the kilometer to the meter, and for the VA, we have the degree there. So we have 35 degree. So with the rectangular method, we can resolve it into I and J components. So we have the value of the VA times the cos 35 in the I component, and uh, times sine 35 for the j component. So we have 135.5 I minus 95.6 j meter per second. So this is the velocity for the A. And then we have the VB. VB is toward the left, actually it is toward the west, but it is toward the left. So 700 kilometer per hour is same as 194.4 meter per second. It is in the negative direction of the I, so it's negative 194.4 I meter per second. And the formula for the velocity B respective to A is VB minus VA, because the question is ask you the speed of plane relative to the plane B. So it is B minus A. Okay, so VB, so we have the ing, so solve in the I first and then solve in the J direction. So you will get the negative 331I minus 95.6 J meter per second, and the magnitude of it is you can square root of the value, and you will get 344.5 meter per second. Okay, so this is the answer for the magnitude of the speed of B relative to A, and then the degree is in the 16.1 degree. Okay, so there is the rectilinear met rectangular method, and for the trigonometry method, okay, you can solve by drawing the speed of the A and B. Okay, so for the B, it is in toward left. So it is toward left. So as here it is toward left, and then for the VA, okay, VA is toward the, this mean okay, like this, and then okay, same like here. So and then the given degree is 100, given degree is 35, but when it is, okay, how to get 145, it is because, so here is, okay, okay, so So this is get the 100 geometry method. So you get 145 here, and then the VBA is the from VBA speed of B relative to E. So
Doctor, your voice not clear.
sorry. Okay, okay, can you hear me?
Yeah, better.
So velocity of B relative to A means it start with A and go to the B. So the VBA is this one. Based on the trigonometry, we can draw triangle based on the parameter given. So from this triangle, we can solve using trigonometry. So the okay, this is the we call it, that means the length of this triangle, square root, not square is equal to length of the side, square root of side, left side plus right side, plus a minus. Okay, this one is v, the formula is for example, this is A, B, this is C. Okay, so C square equal to A square plus B square minus 2AB cos C. Cos this is certain opposite of C. So okay, we can get this alpha, so cos alpha. Okay, so this is the formula of trigonometry. So by applying this theory, so you will get the VBA squared is equal to 118,671.7, and then this is because it is square root of this one, you will get the value of the velocity B relative to A is 344.5 meter per second. It is should be same with the three rectangular method. And also for the degree here, you can solve by applying law of sine. So law of sine is v, that means the length over sine sine of the degree opposite to it is equal to length over sine degree opposite to it. So VBA over 1 sine 145 equal to VA over sine theta. So you should get the theta is 16.1 degree. Okay, so I share another video related to this.
In this chapter, we're trying to find the velocity or acceleration of an object with respect. In this chapter, we're trying to find the velocity or acceleration of an object with respect to another object. So for example, there are two cars going along a road and you want to find the velocity of car A with respect to car B, that sort of thing. You will end up using two new equations. This one is for relative velocity and this one is for relative acceleration. Depending on the question, each of these equations can be written in two ways. So let's quickly go over that. If a question says you want to find the velocity of object A with respect to B, then the equation will be written like this. So VA comes first, then BB, and then it's A over B. Now if the question says they want to find the velocity of object B with respect to A, we write it like this. In this case, B comes first, then A, and then it's B over A. It's important to make sure you get this right and write it properly depending on what the question is asking for, or you will end up with the wrong answers. The same goes for acceleration. The other thing you need to keep in mind is breaking down velocity and acceleration into vector components. In a nutshell, what we will do is break the velocity of object A into components and then the velocity of object B into components. And we will end up plugging those values into the equations I mentioned before. The same goes for acceleration. So let's go over 4 examples step by step and see how we can apply these new equations. By the end, you should be able to solve most, if not all, the problems you face in this chapter. In this question, we need to determine the velocity of plane B with respect to plane A.
Okay, so this
The
is
first step is to establish which sides we will say is going to be positive.
example.
We will assume up and to the right to be
So
positive. Next,
it
we
is
need to break down the
same
velocity
solution.
of each of the airplanes into vector components. So looking at plane A, we see that it's traveling straight down in the vertical direction. That means it will only have the j component because the I component is 0. So it's negative 500j. It's negative because it's going down and we chose up to be positive. Now we will focus on plane B. This plane is going at an angle, which means it will have both components. I've drawn the vector components, so we just need to write them using trigonometry. Drawing them tail to tail will help out a lot. For the I component, we have 700 sine 60 degrees, and for the j component, we have 700 cos
For the
60 degrees.
solution,
Let's simplify this.
it's not
Now
convert
that we have both
the
velocities,
kilometer
we
per
have to
hour
use our
into
relative velocity
meter per
equation.
second.
The question says we need to
Actually,
find
it
the
is
velocity of plane B with
it
respect to
is
plane A.
okay.
So our relative velocity
The
equation
question not if the question not ask you in the unit that it asks, so it's okay to use as kilometer per hour or meter per second. But if you want to change from the kilometer per hour to meter per second, you need to use the formula that I mentioned just now. It is actually 1,000 over 3,600, or you can times divide the value in the kilometer per hour with 3.6. So you will get the value in the meter per second. Okay, so all right. So okay, so we have finished for the relative motion analysis. There is one of the example. I try to share another example after this to make you familiar with the relative motion analysis. Okay, so we proceed to the kinetic. Okay, before we proceed to the kinetic, any question? Okay, Alhamdulillah. No. So for today, for the test, it's only until curvilinear, normal, and tangent. That's mean rectilinear and also curvilinear, normal, and tangent. So you need to know the XY curvilinear, the formula, three basic formula that I mentioned just now, and also okay, for the rectilinear, need to familiar with the graph, how to read the graph, how to change the from acceleration to velocity, velocity to displacement, and so on. Okay, so that is for the test. So for today and previous last Wednesday, I think. The angular also not included in the test. Why is B? Okay, one of you just ask question. Okay. You can hear my voice or not? Okay.
Can, Doctor.
Why is the VBA, the J part is negative 6.6, not 0, minus 6. Oh, okay. Okay, for this one. Okay, for the rectangular, okay, for the VBA is VB minus VA. And then VB is negative 64.4 I. This is in the I direction. And then the formula for the VB minus VA, it has the I and J, but for the VB it only have I. And Hui Yin asked me why that's mean VB minus VA is only take out the negative 65.6J, not 0 minus 65.6J. Okay, right. So that one is, okay, wait a minute. Because for the for the J, it has no value there. And okay, for that one, we need to check back at the degree here. Degree is 60 and 16.1 is right here. So it is actually from this straight line, we have the 16.1 degree there. Okay, so for okay, because for the tan, inverse tan, it is y over x. Okay, so y over x, it is 65.6 over 331. Okay, that one is, okay, yes, I understood, is consider we have the 0 or not. So for this one, because for the 0, okay, because for the end final answer, we want the value of the magnitude and the direction, and then the minus there will influence the direction actually. So you need to check carefully the direction, because for this one, tan inverse, I use the positive one. If I use the negative one, should get shift tan negative 61.6. 331. Okay, so because if okay, this one is negative. Okay, thank you, Eugene. So I will check back if it is a fact or not, the negative 0 minus j negative and positive. Okay, but this is for the trigonometry. You can solve by this triangular. That's mean triangle, and use cosine and sine law. Okay, so we proceed to the kinetics. All right.
Doctor,
Yes.
Doctor, may I ask you something? Can you go back to the previous slide?
Yeah.
May I ask like why they draw the triangle like that? Because if we see from the diagram and we have the horizontal line, we can straight away elongate it and then make it as a base, right?
Mm.
So why they draw like this and then make the angle like 145?
Because the for the start for the uh, direction of the this means for the direction of the B and A should be start at the same point. Yes. So the start point should be same, and then based on this okay, actually it is same as this. So we have the same point of origin. This means the starting point, and the plane A go to this direction, and then plane B go to this direction. So the relative displacement. Okay, this one is displacement, and then the velocity and acceleration also use this distance also. That means the position are same, but just change the formula. So for the VBA, this means just now it is VBA. Right. This means want to know the relative motion of the plane B to the plane A. So relative B to the A, it start the triangle from the A to the B. So that's why it will get here. It will make this kind of triangle, because if you if you this one is toward here, and this one is toward there. So if you want to solve using trigonometry, you cannot just what we call continue this point to this point. Cannot, because this point, this means the arrow is not start with the same point. So for the relative motion, the position, this means the if A like this, okay, the VA like this, and VB like this. So the relative motion is at this direction. So that's why for this question need to solve like the triangle just now. I hope I answer your question. So that means for the relative motion, when you want to solve using trigonometry, you need to solve it by starting both of the triangle at the same point. So if it's not same point here, you need to rearrange the triangle into same point. It's into the triangle with the same point. Okay, so I will share more exercises on this. Okay, but now proceed to the kinetics. Okay, as we learned before, we have learned kinematics. This means kinematics is we not consider the force, but we focus on the how its motion of the particle. But for the kinematics is the sorry, this is kinetic. Okay, previously it is kinematics and now it is kinetic. Okay, so kinematics we consider the geometry of the motion, and for the kinetics it study about the forces causing the motion. So it analyze the relationship between the forces acting on the body. So how the forces acting on the body, and it maps off to the motion. So it predict the motion uh, caused by the given force. So in the kinetics, there are two terms that we need to highlight. There is energy and also works. Okay, works and energy. Alright. So okay. So energy is a scalar quantity that is associated with a system of object. For example, a planet orbiting a sun, masses attached to the spring. So each of this system have energy on it. So there are several form of energy. There is kinetic, chemical, nuclear, thermal, electrostatic, gravitational. So this is the form of energy, and energy possesses a fundamental characteristic which make it is very useful for solving problem in physics, and because energy is always conserved, so it is transfer to another type of energy, but energy is conserved. It cannot if in Malay that's mean dia tidak diperbaharui, tapi dia it is same, it is conserved, but it's changed based on the term of the situation. Okay, so for the first energy, it is one of the important energy is kinetic energy. Kinetic energy is capacity to put another object in motion. So it is energy associated with the state of the motion of an object. So the faster an object move, the greater its kinetic energy. So there is the kinetic energy. So the formula of the kinetic energy is half mv squared. So if the mass is higher, the kinetic is higher, and if the velocity is higher, the kinetic energy is greater. Okay, so I think maybe
Energy, force, work. Still confused? Watch the full video and subscribe to the channel. Let's talk about this example in detail. Energy is basically an ability to do some work. Theoretically, this energy is conserved in a closed system. Closed system is a system that doesn't interact with the surrounding. Now, as the energy is conserved, it means that the energy is neither created nor destroyed. It rather transfers from one body to another and is converted from one form to another. So the sum of the total energy at the end of the process remains same. There are two basic forms of energy. The first one is potential energy, which is a stored form of energy because of the position of a body or an object. The second one is kinetic energy, which is associated with movement
and is found in all moving bodies or objects. Here, the energy stored inside the muscles of the arm is the potential energy, which is supposed to be transferred into the object and is supposed to be converted into the kinetic energy. But how does this energy transfer or convert? This is where the force comes into play, which is basically a push or a pull, and is the only source or a way of transferring this energy. When the force is applied on this object, the body transfers some of its potential energy into the object. But when this force is not enough to move the object, the energy which is transferred is not converted into the useful energy at all. Rather, it is considered to be wasted. Now, when the force is increased, the object will gain kinetic energy and it will move and the work will be done. Note that the work is only done when the force will move the object from one point to the other. The distance between these 2 points is called displacement. So for work done, force and displacement both are equally important. Work and energy are very closely related. They also have same unit, joule. According to the famous work energy theorem, work done is equal to the change in kinetic or any form of energy, which means work done is the final result of the energy conversion at the end of the process, and it can be regarded as the useful conversion of energy, because in reality, the energy is not actually conserved in a closed system. A lot of energy is wasted in the form of heat because of friction. So in these cases, the potential energy, which is then successfully converted into kinetic energy, is considered to be the useful energy, which is indeed the work done. As we know that there are 2 basic forms of energy, potential and kinetic. In addition to these, there are other forms of energy as well, such as electromagnetic, nuclear, thermal energy, and many more. These energies are basically generated because of the coexistence of potential and kinetic energy. Similarly, there are 2 basic types of forces, contact forces and non-contact forces. Work, on the other hand, is equal to change in energy and has no further form or type. By definition, kinetic energy of a moving object is equal to half of its mass times its velocity squared, while potential energy of a stationary object is equal to its mass times gravitational acceleration times height from the surface of Earth. While we know force is the product of mass and acceleration, and work is defined as force times displacement. Unit of energy and work is same, which is joule, which is kilogram meter squared per second squared, while the unit of force is Newton, kilogram meter per second squared, which makes one thing clear, that energy and work have one extra dimension of length, making them different from force. Force is applied in a specific direction, so it is vector quantity, while energy and work are scalar quantities, which means they have no direction. Energy.
Okay, this is kinetic energy, and we have the gravitational energy and uh, elastic. Elastic is okay. Elasticity. Okay, for the we have the gravitational energy. This is the mgh. So we have the also elasticity, energy due to elasticity, for example in the spring, and kinetic energy, the energy for the motion. Okay, so relation work and energy. A force displacing an object does the work. That means the work is the work is when force displace an object, it has work. So the work actually the process of the motion, the process of the movement, it has work. So we know that when an object in motion strikes a stationary object, it can cause it to move. Hence, it can do work. So, the process of the motion caused by the force, we call it as work. But work is a scalar quantity where we not consider the direction of it, but we consider only the magnitude of it. So, okay, as in the video, so energy is capacity of an object to do work. So when we apply force and the object move with certain displacement, work work is done. That means work happen there, and it is because it have the kinetic energy. This means because in the system it has kinetic energy, and one of it is this means the motion. The process of the motion is work. Okay, so work is the energy transferred to or from an object. Okay, because for the example just now, we have the hand and we have the load, and before uh, at first the energy is inside the hand, and then when it's transferred to the load and become the load move, so the work, this means the energy is transferred from the hand to the load. And by transferring the energy, work happen. Okay. This means work is the energy transfer to or from an object by means of a force acting on the object. Because that's mean it is energy transfer, and then energy transferred to the object is positive work, and energy transfer from the object is negative work. Okay, so this is not the direction, but it is a process. So one of definition is when it's transferred to the object is considered as positive work, and when it's transferred from the object, it is negative work. Okay, the work done on an object is the change in its kinetic energy. So work actually is the change of the kinetic energy. And the formula of the work is Fx times the changes of the x. So the unit of the work is joule or Newton meter. Fx is the component of that means Fx is the force in the direction of the motion, and changes delta x is the displacement. Okay, this is the work. Okay, this is one of the, all right. So, okay. Okay, work kinetic energy theorem. So, we can consider that if the change in the kinetic energy of the particle actually same as the net work done on the particle, and the kinetic energy after the network is done is same as kinetic energy before the net done plus the network done. Okay, this is Okay, because for the kinetics, the important formula that you need to uh, know is the kinetic energy is half mv squared, and then the gravitational energy is mgh, and the work is fx or fs. This means the force time the displacement, and the unit is joule. So that is the important things in the kinetic, because kinetics is more on, as in the beginning of the dynamic we have learned that kinetic is more on physics, so it's not mathematics. Compared to kinematic, is more on mathematics, more on equation. But for the kinetics, it's more on theory and yeah, theory. So this is the kinetics, that energy and work. Okay, I think okay, that's all. Okay, this is the end of the syllabus, but we still have uh class next week for the revision and exercises and so on. Okay, so right. So before we end our class, so today I have for announcement. So for the test 2, it will be tomorrow night. We'll have two questions, one from the rectilinear and one from the curvilinear, but the curvilinear until normal tangent only. The total mark is 30. This is 50 mark from the question 1 and 15 mark from the question 2. And same duration, that is 1 hour 15 minutes. And okay, so on next week also we will have a quiz too regarding all the dynamics topic. It will be objective question. Think before the class, and that's mean we will start the quiz first, or I will inform later about the quiz, and then the assignment, you have the assignment 1, that is the static assignment. There is both of the assignment is grouping, and for the assignment 1 is on static reaction, and for the assignment 2 is on the question on the dynamics, and both is deadline is 30th June 2022, and the last one is EPP, penilaian pensyarah. Okay, so okay, so this one is to evaluate my teaching style. So you go to the AIMS web and go choose, okay, and then from the AIMS web, choose the EPP. So you will evaluate my teaching style. Okay, that's one is from this mean for the EPP, you will evaluate my style through the, I think it is objective and comment, right? So that one is about the EPP. There's a UTM system, and I also want to have your comment. So please write here either the same comment that you write in the EPP, or other comment to improve my style, or to share anything here, and include if you want to, if because we have one more weeks because before the study week and the final exam, if anything you want me to highlight during next week, you also can share in this comment. That's mean in this Padlet, anything about the my teaching style, or anything you want me to stress on exercises, that's anything you want to share, please share here. And if possible, write your name. Okay, okay, that's all. Any
Doctor,
other question?
Doctor,
Yes.
I want to confirm again the syllabus that will be included in our test too, because I think for the last virtual class, Doctor only mentioned that the test two will be only including the rectilinear motions and the rectangular coordinates of curvilinear motion. So
All right. Okay. So, sorry because that time I think until because for this test two it is from me and also another lecturer, and that time we discuss until rectilinear rectangular, but uh, maybe he misunderstand the discussion, so he prepared the question from the normal tangent. So yes, we have the question from the normal tangent also. Okay, sorry for the inconvenience because because that part is from other lecture. So we already, this mean we already compiled the question. So yes, the question is rectilinear, curvilinear, rectangular, and also the normal tangent. Okay, any other question? Yes. What question you have, Dominic?
No, doctor, I was just agreeing with Jenny's question because like
Okay,
uh
sorry.
before this was like rectangular, now like one day before it's now normal.
Okay. But for the normal tangent, the important is you need to know the acceleration in the normal and tangent. That means the acceleration in the normal is v squared over rho. So there is there's the formula that you need to apply for the normal tangent analysis. Okay. If no other question, please share any comment on the Padlet, and also evaluate me in the EPP. Okay, yes, I will share this slide. The previous slide, all of that I already shared. Just sometime maybe I miss the slide. I also I also share the video from the YouTube. So if you want to have another version of the lecture, that's mean actually is same. That's mean from me also, but maybe because maybe there are some details there, so you also can refer to that lecture from the YouTube. Okay, so if no other question, we will meet on Thursday night for the test 2. Okay, good luck.
Doctor. Thank you, doctor.
Okay, you're welcome.
thank you, Doctor.
You doctor.
Thank you, doctor.
Thank you, Doctor.
Thank you,
Thank you,
doctor.
doctor. Assalamualaikum.
Thank you, doctor.
All right.
Thank you, doctor. Bye bye. Good night.
Good afternoon.